Hi everybody, Miss Suchi here again. We are going to continue by going into lesson 4.5, Congruency Shortcuts, which is just an extension of our last geometry lesson. Today's objectives are being able to use the ASA and the SAA congruency shortcuts, and knowing why AAA is not a congruency shortcut. So let's look at our first information here. Oh, these are our review questions. So last time we figured out that the SSS and the SAS congruency shortcuts do show us that two triangles are congruent. So you can see in this first example for side, 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 we have 3 matching side lengths for each triangle. Now these matching sides are only giving us 3 pieces of information, that the 3 sides are the same. But this implies that all of the other parts do match on each triangle. So those triangles are congruent. On the side angle side congruency shortcut, the same situation happens, except we're talking about 2 sides that match and 1 included angle. Now again, that's only 3 pieces of information, but as we saw, this does imply that all of the pieces match up. So these triangles are congruent. Here, if you recall, the side-side angle congruency shortcut is not one that makes triangles congruent. Remember this word here? If we rewrite it in the opposite direction, not a good word for school. So, looking at these parts, the difference here is that we do have 2 sides that are matching. But this time, it's a non-included angle. And so that's why the angle is on the outside or not between the 2 S's. So here, these triangles may not be congruent. Now, last time we talked about included angles. This time, we're going to be looking at included sides. So to be an included side, it is a side that is between 2 marked angles. So here you can see this yellow side kind of has like his hands, 2 hand friends next to him. So he's included in the group. So looking at this one is the ASA congruency shortcut, one that works. And this has the S in between the 2 A's, which means we're looking at an included side along with the 2 angles. So let's color code these. Here I have a double arc mark in corner A. That matches with the double arc mark in corner X. Single arc mark in corner B matches the single arc mark on corner Y. Then we have our included side, AB and XY. Okay, now these are 3 parts that match on each triangle. But I need to be certain that that implies all of the parts match up. And I'm not given a lot more information. So I'm going to look at the next example to make sure. In this example, we have a lot more information going on. Here you can see the orange angles match up, the blue angles match up, and they have a side that matches up. So here, this side is between the orange and the blue angles. This would also be an included side. But I do see one more piece of information, and that is this parallel marking here. Now, when we have those parallel markings, it is implying that the orange angles are equal because they are alternate interior angles. It is also implying that the blue angles are equal. And so on this example here, we have this extra piece of information, but it does not mean that the side lengths are the same. It is only implying that the angles are the same, which happen to be marked for us already. So I'm going to erase that little part there so I don't get confused. Now, these two triangles certainly do look a lot alike, but I'm not totally sold yet. So let's try another example. Okay, double arc mark, double arc mark. Those angles are the same. Single arc mark, single arc mark. Those angles are the same. Included side, included side. Okay, so here we have another one that looks like the two triangles do match up. And if we were to continue this investigation, doing more and more examples, we would find that when we have two angles in an included side, or ASA, then the two triangles do come out to be congruent in all manners. So here I have the ASA congruence conjecture. If two angles and the included side on one triangle are congruent to two angles and the included side on another, then the triangles are congruent. Great. So I could go back up to this example here, and I could say triangle ABC is congruent to triangle X, Y, Z. And that is because of angle, side, angle. Now again, the order that I picked these three letters has nothing to do with the type of congruency shortcut it is. The order I picked for my first triangle is based upon what I prefer. The order of the second triangle is because of the color coding matching, or the parts that are congruent matching up. That's why we call them corresponding parts. All right, here's another congruency shortcut to test out. This one is the side angle angle. Wait a minute. Our last one was angle side angle. So they both have two angles involved. This one had an included side. This one, the side is not between the two angles. So it is a non-included side. So let's give this one a whirl. Length of 4 between A and C matches this length of 4 between F and D. 80 degrees and 80 degrees. 30 degrees and 30 degrees. These two triangles sure look like a mirror image of each other, but I can't be certain yet. So let's do another investigation. Okay, on this one, single arc marks match, double arc marks match, and a side that is not included matches. These ones look the same too, but let's just double check. Okay, here's another example. Single, single, double, double, and finally, the non-included side is the same. Well, this example looks like it matches too. And in fact, if we were to continue this by trying different triangles, we would see that yes, in fact, anytime a triangle has two angles and a non-included side congruent to two angles and a non-included side on another triangle, these triangles are totally congruent. Now, this name could be written as angle, angle, side, just like we could flip around that other one that we won't mention. The reason why we want to make sure we see it in both directions is because you might not notice the side right away, and you might notice the two angles first. But remember, this is a non-included side, and that's because it's hanging out on the end of our congruence conjecture shortcut. If it's in the middle, like this example here, this is called an included angle, or sorry, an included side. And that would be a different example from what we have here. But let's finish our conjecture. If we have side angle angle, then the triangles are congruent. Great. Finally, our last one. In this example, we are looking at AAA. Well, that reminds me of an example we did our last lesson, where we had three angles the same. So 60, 60. Hey, another 60, another 60, another 60, another 60. Weird. Well, this one happens to be an equilateral triangle or equiangular triangle. So that means all their parts do match up. But notice we have two different side lengths. And that's because if I were to take a picture of this equilateral triangle and print it out on a photograph, it would be the same triangle, just in a smaller version. So right away I can say, no, angle, angle, angle does not necessarily make two congruent triangles. Okay, well, I have one non-example. So right away that disproves this conjecture. But let's look at another example that's not equilateral. Here I have a single mark and a single mark, a double mark and a double mark, and then a single curve and a single curve. So here again I have three congruent matching corners, B and R, A and P, C and Q. But clearly they are not the same size. And again, that's because one could be a shrunken version of the other. Finally, we have an example with some numbers. 60 degrees matches, 80 degrees matches, and 40 degrees matches. And again, we have one that is smaller than the other. So these ones are not congruent as well. So AAA congruence conjecture. If three angles of one triangle are congruent to three angles of another triangle, then they may not be congruent triangles. Now I said may not because maybe they are identical, but they might not be. One might be smaller than the other. All right, let's practice. So what we're going to do is we're going to figure out, is this ASA, SAA, or maybe it's angle, 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 which was not good. Or maybe we would have a side, 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 angle, side, or that heaven forbid one, side, side, angle, or angle, side, side. So let's do some highlighting to figure out what we have. Here I have a single mark. Here I have a double mark and nothing else. And these two triangles are not touching, which means I don't have enough information. I need to have at least three parts to compare them. So this one is cannot be determined. Our next example has double corners, single in the corners, and then they share this included side. So here we have a pink angle, a blue side, and a yellow angle. Now I notice that the side is between the two angles. So this one is angle, side, angle, which is a proven congruency shortcut. So these two triangles are congruent. Our next example over here on the right, we have a 90-degree corner, triple arc marks, and double arc marks. Now these two triangles, they look the same to me. But because this is angle, 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 A, 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 we cannot for certain determine that these two are congruent. So this one again is cannot be determined. You could also write that they are not necessarily congruent. All right, in this example, we have an arc mark that's the same. We have a hash mark that's the same, but there's nothing else marked the same. This is where we have to use some of our math skills. Because these two triangles are meeting together at vertical angles, these two angles here and here are also congruent. So I could put some arc marks in there showing that they are also congruent because of those vertical angles. Now with those pieces of information, I have two angles and one side that match two angles and one side of the other triangle. So is this a good one or a bad one for our congruency shortcuts? I can see that this pink side is not between the two marked angles. So this is a non-included side, meaning I have angle, angle, side. And if I look at the other triangle, it follows that same pattern. It's also a non-included side. So if I think back to my congruency shortcuts at work, this one right here, side, angle, angle, remember we can reverse that and write it as angle, angle, side. So these two triangles are in fact congruent. All right, here we have 90 degrees in this example, a single arc mark, and then a shared common side. So here again, I have two angles and a side, just like this last example. But this time, the side here is actually smack between the two angles. So this is angle, side, angle. And if we look at the statements up above, angle, side, angle was a congruency shortcut that worked. So these two triangles are congruent. Finally, we have two corners that are the same, and we have a shared side. This example is identical to our last example, where we have an included side between the two angles. So these two triangles are congruent by angle, side, angle. And that concludes our lesson for 4.5.